Hello, Jean-Charles.
Hello, Pierre.
Nice to have you here in Louvain-la-Neuve. So we were asked to produce a small video about you because you were nominated as ACP recipient award a few years ago, and I was part of the nominators. So I take the opportunity that you visit us to make this small video. So how are you doing?
I'm doing well. I'm happy to be here in Louvain-la-Neuve. That's always a pleasure to be here. It's different from France, and it's quiet for me. And I like to be here in a place where I can meet a lot of young students and promising students. And so you have a nice team here, and I'm always happy to be here.
Thank you. So I will ask you a few questions. You can always use a joker to say this question is too difficult. I don't want to answer this.
Okay.
So I will start with a very difficult one.
Yeah.
I know that it's a difficult one for you. So what is constraint programming?
So constraint programming, that's a good question. And I think that in general, this is a method to combine the power of the human brain and the power of the computer in order to solve a combinatorial optimization problem, discrete in general. And so people know what constraint programming is now because they are used to solve a Sudoku problem, and the reasoning that they use to solve Sudoku problem are constraint programming, in fact. And so this is a general model in which you just have to define variables and constraint involving these variables. And then normally you push a button and the solver is going to solve your problem. So this is a general answer.
Yeah.
But behind that, you have a lot of work to do to obtain the result.
Thank you. Very good answer. So it also means that if the constraints are clauses, logical clauses, that's also constraint programming?
So in constraint programming, in my opinion, you should have a kind of human reasoning which appears somewhere. So one of the main ideas of constraint programming is to try to keep the structure of the constraint of the sub-problem of a problem. This is also a way to solve a general problem by splitting your general problem into sub-problems that you are able to solve and to combine the solving of the sub-problem. So in my point of view of constraint programming, I think that what is important is to explore the structure of your problem, and so when you reach a low level, this is too much low level, then in fact it's no longer constraint programming for me, because you lose this part of the clever combination in a similar way that you can do when you try to solve your rastering problem or your Sudoku problem on some other problem.
I see. It's true that you don't want to solve clauses manually.
Yeah.
So I understand. Okay. So you are professor since when?
Since 13 years now. I think that it was in 2009. So it's not 13, it's almost 15.
But before that, you were working as a PhD student, and then you joined a company.
Yes.
Called?
iLog.
Can you say a little bit what you did during your thesis and then what you did in this company, iLog?
Okay, my thesis at the beginning, my thesis was about the development of machine learning system to predict the interesting bounds in organic chemistry in order to if you want to build a molecule. And then I had some problem with the system, and because I like to do some algorithm and things like that, I was working on the subgraph isomorphism problem, because in the system machine learning, in the symbolic machine learning system that I developed, we try to generalize the molecule, that is the graph representing the molecule, and then we had a problem of subgraph isomorphism to solve, and then I was considering different algorithms, and notably the subtree isomorphism problem, in which there is a kind of all different constraints. The subtree algorithm is polynomial, and whereas the subgraph isomorphism is not. And so I was working on that, and I was in Montpellier, and in Montpellier there was a team in which, for instance, there were Christian Bessière was also a PhD student.
At the same time as
At
you were?
the moment, at
I
the
didn't know
same time. Then Christian became a researcher, but at the moment we were both PhD students at Montpellier. And then Christian published something like AC6 algorithm.
Okay.
And so I began to work with Christian on that kind of algorithm. And then at some time, I not solved, but I proposed another way to solve the subgraph isomorphism problem, and I proposed to use a constraint which is well known now, that is the Awardee constraint.
Because you need to match.
Yeah, I need the match.
Two graphs.
Yeah, two graphs.
And the
to know if
if
a small graph is a subgraph of a bigger graph. And so the idea is that you need to put the node of a small graph on different node of the big graph. So this is an important problem.
But that problem is an NP-complete problem?
That's an NP-complete
We didn't
problem.
know. It's
No,
it's
an
an
NP-complete.
Okay.
The graph isomorphism is an unknown problem.
Yeah.
But the subgraph,
The subgraph
and you have different subgraph, different variation of the subgraph isomorphism, partial or not partial. And this is an NP-complete problem. So I developed a constraint.
But your advisor was not at all in CP at that time. CP did not exist.
My advisor was not in that topic. My advisor worked in bioinformatics. So my advisor was not someone from Constraint programming. And so he was more involved in machine learning, and especially in bioinformatics, and is now at the Academy of Science in France. And so he gave me some freedom, and I have no problem about the knowledge of the support and the scientific support, because Christian Bessière was close, and the Constraint programming team was close too.
Yes.
And when I proposed the Awardee constraint, and then I was contacted by the iLog company, who was developed its own CP solver, and who proposed me a job.
It was in what, 97?
95.
95. So
95.
you attended the first CP conference in 95 as well?
Yeah. So in the first CP conference, it was my job interview during a lunch of that conference with Jean-François Puget and Patrick Albert. And I remember, so we drank a little bit. And it was in Cassis. The sun was hot, and so we decided something. And I remember that people told me, "Oh, you have to propose a salary." And then, for instance, you say, "Oh, I need to go to the toilet," and then so you give them some time.
Trick.
And that was a nice trick. So then I started to work in iLog in January '96.
Okay, and then what did you do for 10 years, 20 years?
Yeah, 12 years.
12 years.
Yeah, and so I spent 2 years in Paris first. And I was in the group and involved in the development of the CP solver. And then I became the manager of CP solver and the director of Constraint programming. And so at the beginning it was very, very nice, because it was a real R&D teams. And,
so there were no Cplex at that time, only CP.
Only CP, and it was the company it was very nice, and the people the discussion were incredible.
Yeah.
It were really interesting and things like that. And then the company decided to merge with or to hire Cplex. And so things changed a little bit, notably about the merge of the two companies, and we developed something that was special, that was named Constraint. And it was certainly not a concert to develop Constraint. and then, but it was okay. And the people of Cplex were very good people, and we very strong skill in MIP. And so it was interesting. It was difficult, but remains interesting. And then the company changed a little bit and became more software developer company or something like that. And the R&D aspect, I think that was less important in the company.
Yeah.
And so it was a little bit different. So I moved to the south of France in Sophia Antipolis in 1908. So that was 2 years after joining the company. And then an event happened in 2004. I went to Banff. To a conference.
That's the ski accident.
And then I gave a talk. I was arriving in Calgary in Saturday, I think. I gave a talk on Sunday, on Monday, on Tuesday. And then Louis Marcin Rousseau asked me if I want to do some ski. I think it was Tuesday afternoon, and then we were skiing, and I broke my shoulder. And I broke my shoulder. I had a dislocation shoulder, but not the classical one, the not classical one at all. That is a posterior dislocation shoulder. I have no luck. That is, they were not able to discover what I had, so that was a real mess for me.
Yes.
And but it gave me some time to think about what I want to do in my life, and so I decided to take a sabbatical.
Yeah.
And
at a university?
No, I was not at the university.
But the sabbatical. No, it was at home. At home.
When I was at home.
Okay.
When I was sick at home, I decided to take a sabbatical, and so I spent a sabbatical in 2005 in Cornell University.
Yeah.
And then the company was changing a lot. That is more and more a company focused on business rules and things like that, and more important. And I wanted to change at that moment. At that moment, some people left the company, like Laurent Perron, like Claude Lepape, and so on.
And so you decided to come back at the university.
Yes, so the idea that at the moment of the buyout of IBM, and then I decided to go to the university. And then I spent 1 year in the university giving courses because it was a lack of my file that I didn't give.
Yeah, you really enjoy teaching.
Yes. And of course, so I really enjoy teaching, and I got a position as professor in 2009.
2009. Yeah.
And I logged in 2008.
Okay, I would ask you, because you have many papers published at CP conferences, CPAOR, can you tell me a little bit the relation? Why did you started this conference, CPAOR, although CP did exist at that time? What was missing?
So in fact, I mentioned that last year, because last year I organized the 20th CPAOR conference in Nice again, because we organized the first one. So CPAOR was a workshop, and in which Michela Milano and Ulrich Juncker were involved. And then Jean-François Puget asked me something about the transformation of the workshop into a conference, because we needed a place that were more in relation with the solving of the problem, of the real world problem. And also with another community, which was a community more involved in the solving of real world problem, the operation research community. Yes. And so we decided to transform that workshop into a conference. For the story, at the beginning, the idea was nice, because the idea was to be more formal. That is the advantage of being a conference, is that you have proceedings, real proceedings, and official proceedings. And so, but it was not so obvious, so we were not sure. So we decided, Jean-François asked me to do that, and so I contacted some people. Yes. To see what they think, what they thought about that idea. And what was funny is that I think that we take with Jean-François a political decision. That is, the poll we made was not in our favor. So we decided to ignore the poll. And then we say, okay, we are going to organize it.
And the poll was saying, okay, we keep it as a workshop.
Yeah, the people were not really in favor.
Okay.
No, they say, it's going to be a competition and things like that. And I say, no, this is an alternative. This is something which is more oriented to the solving of problem, and the goal was not to be a competitor of CP. That's not the idea. Is that, and the proof is that we continue to be involved in CP and CP AIOR. The public are a little bit different, but especially at that time. And that we needed to be more focused. For instance, in the first one, we invited the director, the R&D director of ACP company and things like that, in order to be more involved with and a lot of in general in CPIOR you find more people coming from the industry and companies using CP in the industry or MIP, because CPIOR is more open too.
Yes, that's
true. And it was not really AI at that time, but now it was a good idea to put the AI. So now
that was my next question.
Who
did find the name CPAIOR? Because 20
I
years
think
later,
that it was the name of the workshop. So I don't remember. And I know
remember?
No, I don't remember.
Because the person who chose this name is a genius.
Was a visionary. It was really visionary, for sure.
So you have many contributions, many papers, but I would ask you to select your 3 favorite papers or contributions. So which one would you choose?
So the first one, without any doubt, I will choose the old diff, the paper about the old diff. It was the first paper that I wrote, so it was not a bad paper. I think so.
But you did not invent the matching. You did not invent the strongly connected component. Your idea was to use both existing ingredients.
So in fact, the problem that I had at that time is that I didn't understand, because if you, for instance, consider the PhD thesis of Laurier, you will learn that Laurier proposed, in fact, the first system, but he said, we have an issue is that we are not able to solve the matching problem. And so for me, it was a strange question, because we know that the matching
is polynomial.
So my question was, why should we be able to, why is it so much important to solve a polynomial problem? This is an interesting question for when you develop a solver. To wonder if you are able to solve easy problem with your solver that is made for solving non-easy problem. But it remains an interesting question. But I was wondering, why should we go in that direction? Because we know how to solve this problem. So why we should not? The other opportunity was to say, okay, but why we shouldn't use the polynomial complex algorithm for solving some complex constraint. And it was really the idea. Because in the global constraint, you have 2 aspects. You have the first aspect is the expressiveness. That is the fact that if you don't have a global constraint to express that a set of variables may take different values, the problem is that you have to write 2 loops and defining a local constraint within the 2 loops. And so it's not really pleasant to do that. No. So for the expressiveness, we had a lot of constraints like that. When with the expressiveness, they discovered that in fact they gather some small constraints together, and it was the idea, because they gather some small constraints together, it was the idea to say, that group of constraints now is a kind of global constraint, because I see a global of local constraint. But in my opinion, it was more a constraint is a constraint. And so now what constraint programming is, it's just the fact that I associate with each constraint a filtering algorithm. And my filtering algorithm can be easy, like X is less than Y, but can also be complex, like the search for a feasible flow in a graph or things like that.
But coming back to your PhD thesis, was it useful experimentally to use this one?
Yeah, because in fact it works pretty well, and currently this is the basis of the subgraph isomorphism problem, is to find all diff constraint.
But nobody had the idea of using a maximum matching to solve the isomorphism. Subgraph isomorphism problem.
It's true for the tree. That is, when you look at the tree isomorphism, you have things like that. But what you have to understand is that we are the positioning of what we did in constraint programming is a little bit curious in the world, is that we don't solve polynomial problem, and normally we can't solve NP-complete problem. So we try to solve NP-complete problem, but we can't claim that we solve all NP-complete problem, because we have the P versus NP question.
So that's your favorite contribution, and I also think it's a brilliant idea, because anybody teaching CP, I think, which is your algorithm.
Yeah, so
but that's probably a proof that it's an important contribution.
Yeah, this is very nice to see that and to see some feedback from the Constraint, and so I'm happy to have that kind of thing. The second thing is that I think that I worked a lot on the basic R consistency algorithm, like the AC67 2001 inference.
So what is it about?
So the question is that when we have constraint given in extension, that is that
what we call a table constraint.
What we call table constraint nowadays, and that are you have all the combinations that are allowed or forbidden for a constraint, and this define your constraint. And the goal in constraint programming is to eliminate the values that do not satisfy the constraint as quickly as possible. And if you eliminate all the values that do not satisfy the constraint, then you establish R consistency. And so these are the R consistency algorithm for constraint defined by all the combination. And so you have to eliminate the values that are not what we say consistent with the constraint. And so this is very important. It remains very important topic. So I publish on this topic for more than 20 years. And there are some algorithm. Recently I published with Pierre another algorithm on compact table, which is the latest version of this thing. But I still think about some new algorithm. And this is a part. And I receive with Christian Bessières and some other people the Classic Paper Award from Artificial Intelligence with Zhang and what is the name? Roland Yap. It was Roland Yap. And with Christian and Zhang, we received the Classic Paper Award in 2020.
For an algorithm for table constraint.
For an algorithm for table constraint, which was a simple algorithm. So these are my okay, not this one or another one, but these are two important contributions in my life. And for me, the last one is a little bit complex because I wrote and I worked on different problems. And this is a good question.
Like the traveling salesman problem recently.
So recently we worked on the traveling salesman problem. And so it was a very important topic, and I decided to work on that because one guy told me in my life that if you want to do some interesting thing, you should consider a very difficult problem, because if you solve them, then you will be famous and you will find great advancement. But even if you don't find great advancement, you will find very interesting stuff because the problems are very difficult. And so this is what we did, and I think that it was very good. But I also produce MDD algorithm with a graph and breadth first search point of view, which are not bad, which are used and that change the thing for the MDD. And I also, there is one part that I like also is a part on the over-constraint problem. Is that with Thierry Petit, we made a job that is a complex job because it's the combination of an academic, I think, and an industrial job. Is that I remember that Thierry Petit met all the consulting people in iLog, or some consulting people in iLog, discussing about the way they deal with that kind of problem that are very common and too much in my opinion, in constraint programming. And so we develop some general things like the soft global constraint with general cost, that is how many variables you need to remove from your constraint to be able to satisfy it, or what kind of
how many values you need to change
and things like that. And so it was a very interesting.
That's your choice number 3.
Maybe my choice number 3, I think.
Okay. Thank you, Jean-Charles. I would like you to tell me about, let's speak a little bit about deep learning because it's a very trendy topic. So do you think that deep learning, large language models, and this kind of new stuff in AI could have a positive impact on CP, or you don't think that it will impact at all constraint programming?
I think that when you have a new technology with a huge impact, in general, you will have an impact in your community. However, in CP, that's a little bit difficult because what we have is that, in fact, we don't solve any NP-complete problem, and we don't really improve the solving of that kind of problem with machine learning. That kind of result is a little bit missing, that the solver did not really change with that. We can have improved some result or something like that, but combinatorial optimization problem are combinatorial optimization problem. And I worked recently. I work on the combination of LLM large language model that is kind of ChatGPT with constraint programming. This is interesting, and I work on that for problems that are dominated by the constraint. That is, when the problem are when the text generation is dominated by the constraint, you have to solve first a kind of combinatorial problem defined on words, and then make the thing such that it's a natural language. It's a sentence in the language.
So you use it more like a heuristic?
Yeah, it's a guide. We try to use it's a guide to improve us on the definition, on the part of the definition of a sentence, something like that.
But you think
on the machine learning, we can do something.
But for the modeling, because
I think for the modeling we can do some. I think that machine learning in general we can did something. For instance, I propose a work where we just notice that when you have a set of solution of a problem, you just have an MDD. So you can deal with MDD techniques to deal with that and to recognize constraint and to think like that by defining an inclusion between MDDs. But I think that I would like to see more result, but unfortunately we don't have more strategies and things like that. We don't really understand. For instance, when we want to do some shaving, it's very difficult to understand when we have to do that because if we were able to define when it is worthwhile, it would be a great advancement too. But I don't know.
Yes. Okay.
I don't know, but I don't see the result. The result for us, maybe when the problem are too much structure, too much constraint, it's very difficult to avoid the combinatorial part, and that's a little bit different. I like to explain to my students that the deep learning and things like that are another way to see the problem, and the goal is to simulate the human behavior. And for instance, to recognize if it's a dog, if it's a wolf, and things like that. But we in constraint programming, we remain in the previous way to tackle some problems. That is, I try to understand the problem, I try to modelize the problem, I try to solve my problem.
Yeah.
And so I can explain, for instance, with constraint programming. Whereas with deep learning, since I try to simulate, it's different. It's more difficult to simulate. So we see some interaction when you want to predict and when you want to manage the temperature of a room.
So yeah, it's true that deep learning, they try to create AGI, but with constraint programming, we are trying to solve problems that are out of reach for human persons. So I personally find it more exciting.
Yes.
So can you say a word about what your students think? Because most of the time for PhD students, they hesitate between machine learning PhD and maybe constraint programming PhD. So do you think that we still have assets to convince a young person?
I think that it's more and more difficult. It was not 5 years ago, it was a little bit different. So now it's a little bit more complex because 5 years ago, not a lot of young people wanted to do machine learning, but now we have really a lot of requests. And they don't understand everything. But when you show that I have some students that did that like very much constraint programming. Sometimes they did different things, like Guillaume Perez, who was doing machine learning for some time, and now he's back on constraint programming because he thinks that it's more fun. It's like what I say is that constraint programming on some aspect is fun. It's funny, honestly. And you have less mathematics. You have
less parameters
to tune. You have also one thing that you can imagine something and to try to transfer what you think into the machine and to look at what happened.
Yes.
and to analyze the thing and to see the different thing. You really understand. You really have you have the impression that you have an impact, and so this is a nice sensation, and on people like that.
Yeah. So when you look at papers accepted to your favorite conference, let's say CP or CPIOR, what are the first papers that you want to read?
So the first paper I want to read that are papers that solve, in general, problems that are real-world problems or well-known problems and improve the solving of well-known problems. Because I always think that, for instance, if you are able to close a problem, your paper should be accepted. That because even if your method is stupid, because it's never stupid when you close an open problem. Nothing is stupid. Even if it's very strange, but it's never stupid if you're able to do that. So I think that these are things that really improve the comprehension of some mechanism. So maybe we don't really understand what is behind such a resolution, but I'm pretty sure that we will learn a lot of things. And so I recommend that thing. And I want to see some paper that consider application and propose something new for an application, so either existing or not existing. And then my regret also is that it's difficult we don't see enough paper about the solver. But it is general and it has always existed. And so it's very difficult, unfortunately, it's very difficult in our community to publish paper about solvers, so about techniques of solver.
Because it's considered as implementation details, or why?
Maybe, I don't have any explanation, because I think that sometimes when you don't implement, you don't realize how much it can be complex and time-consuming and difficult to implement efficiently something. And so now we have a lot, for instance, even if you consider a shortest path, now you can find maybe, I don't know, but you can find library, but you can find 20, 40, 50, 100 papers about the computation of shortest path. And now you find different papers, because you have papers that also consider graph having millions of nodes, but shortest path, for instance, in CP will be used when you have 100 of nodes. And so the algorithm and the performance can be difficult. And things like that, it's very difficult to explain that to people who are not used to develop.
So you complain that some papers are not accepted while you would prefer to see them accepted. So what do you use as a criteria when you are a reviewer to decide that a reviewer should accept a paper or should reject it?
So now it's a little bit different, because I have a lot of PhD students, a young student, and I can tell you when a first-year PhD student write a paper, or when you almost write the paper of the student, and that you help it, and that when you receive very harsh review, very strong negative review, it's very difficult. So it's very difficult for the young person, and I know that a lot of people complain about that. And I think that most of the thing that I want to say two things is that the opinion should not be too much subjective. That is, you can have a subjective opinion, but the first thing when you review a paper is to make sure that the paper is sound and that
no mistakes.
No mistake, and does not contain mistake. And then it's original too. That has not really been published, but really that is what is very difficult is that this paper looks like another paper that I read 20 years ago. You should look at the past CP conference proceedings or things like that, and if it's not precise. I think that when you want to complain about something, your role as a reviewer is to be precise. Is that to say, look at this paper, I'm sorry, but I don't see the difference with this paper. Or if I don't understand something in a paper, I make an effort to try to understand, and then I have some limit as a reviewer, so I'm not able to understand. There is no problem. We can think like that. But please, avoid the comment like the one I received once in my day, which is the bullets are ugly. This is very difficult comment for a young student, because they were thinking that science is a very nice thing, very beautiful and very serious thing. And when they receive a comment about the size of the bullets in the paper,
Yes.
they are very badly surprised.
It might be just a tip to improve the look and feel of the paper.
Yeah, but
that's
not so important,
That's
in
not so
my
important.
opinion. In my opinion, what is the most important?
So what do you use as criteria to say this one we should accept it?
So to accept a paper, Alain Colmeroer told me, I think that it was during the first CPI Award conference, when you have a paper, if you reject it, you have to put it in the bin of your office. Okay?
You should not keep it.
You should not keep it. Because if you keep a paper in your office, it's mean, or on your laptop now, it means that your paper has some interest. But if it has some interest, you really should consider if you should accept it or not.
So according to you, if at least one reviewer find it interesting, it's probably a sign that it should be accepted.
I say that if one reviewer thinks that the paper should be accepted, I think that if you think that there is something interesting in the paper, enough interesting that you are ready to keep it into your office or in your laptop, it means that you should accept it.
Yes.
You should be in favor of accepting. The other reviewer can have different opinion, of course, and so the paper can be rejected at the end.
Yes.
But the goal is a lot of people make a lot of effort to write the paper, to try to explain what they do. And currently, I think it's too much difficult to publish original stuff, because people are not ready to accept that, okay, this is very original, or the positioning of the paper is difficult to establish. It's not so easy to say something. And Michel Ruher had a remark which was interesting. He said, okay, you cannot say this paper has not application, and at the same time the paper is very original. If the paper is very original, this is new, so this is normal not to have so many applications.
Yes.
When it will be used, it will have more applications. So at the beginning, when you propose something very new, it's very difficult to say, okay, look at the lot of application, or we want only a Word paper.
Yeah. So do you value the fact that some papers are more reproducible than others because the source code is shared? Or it doesn't matter for you that the code is available or not?
I think that it can be important for the code to be available, honestly. But at the same time, I think that paper don't need to have experiment, for instance. So now you need to have experiment in all papers. But I'm not sure that this is mandatory. That it was not the case previously, and it was not so much important. I think that sometimes
the
you don't need
paper
to, as almost no experiment.
No experiment,
Okay.
Nothing at all.
In the first submission, there were nothing at all, so it was resubmitted with just a few experiments. I think that your experiment should be reproducible. Okay, this is, in my opinion,
enough details.
You have to be honest. You have to give enough details. Okay, and you have to be precise, and you have to be honestly. Even, for instance, even when I was in iLog, some people ask me sometimes to solve a problem with, I remember, the ClickMax algorithm. And then I say, okay, I can't give you the code, but you can give me your instance and I will solve it and send you the answer. And this is what I did. And I remember I had some communication with a Canadian guy working, I don't remember where, about that kind of thing. And the reproducibility is very important in science because, what we have to understand is that we have to be careful about paper having experiment just for the paper. That is, that's not really interesting. That is, okay, these are the kind of paper, you read the paper and you say, wow, this is very specific thing, very okay. How the author are able to sell that wow, they find a bench. Oh, wow, they invent a problem. Wow, in fact, the real contribution was the problem they were invented in order to support their claim. Okay, we have some papers
Yes,
like that,
yes.
and we have to be careful about that. And so sometimes we also, I remember making a joke with you about the review where we were complaining because we say, how the reviewer didn't see any experiment that has absolutely no relationship with the content of the paper. But he would like to see that. And so we have more and more and more paper like that. And more and more requests, about like that. And that is, you have some experiments, some people want to see some more experiments, and then after a time, they don't want to see the experiment that the first reviewer want to see, and so on. And
Yes.
so very complex. At the end, the paper is the paper of the authors. The paper are not the paper of the reviewer. Okay, that are the paper of the authors. And if something is badly written, and if something is not precisely defined and things like that, okay, but this is the responsibility of the authors.
Yeah.
And so, for instance, it's very difficult. Sometimes we add because
I see what you mean. Jean-Charles, I know that you have implemented many solvers, even at the university, but they were never open source.
never
no.
mentioned. Yeah.
But can you explain, would you advise to a young PhD student to also implement his own solver for publishing his paper, or should he rather use an existing off-the-shelf solver like Choco, for instance, or something else? What are the advantages and disadvantages?
I have several remarks about that. The first remark was I had a discussion with Philippe Baptiste when he was giving the course at the École Polytechnique in France. That is a high-level school with a very good student. And Philippe Baptiste told me, well, when I present constraint programming, they look at me in a strange way and they consider that this is not interesting. And then I ask them to make a small solver, and then their opinion changed. And when I ask my student, for instance, my PhD student, when they leave the university, about the courses, what they liked, they almost all answered to me that it was very nice to develop a small solver. And this is when they develop a small solver that they understood different things. They
Like
understood the reversibility, the fixed point, the fact that the backtrack is a difficult task, and they understood a lot of things, and one we need to be general in some part and things like that. So I think that in the course and somewhere, they need to develop something. This is why something like mini CP or things like you like to do are good, because in my opinion, this is a good thing to do that. Now, for publishing, it's different. I remember when I worked on the parallelism of the CP solving, and I submit a paper, and that my paper received something like 6 reviews. Wow, but it was accepted. And a big discussion. And Christian Schultz, unfortunately, who is dead now, Christian told me, you know, Jean-Charles, what was very interesting in your paper, is that you presented a method and you apply it to different solvers. That is, you use your R tool, G-code, or I think Choco. And he told me this is very rare and this is very interesting. And so I think that when you publish a paper, you should consider the existing solver. And when you present some method and things like that, I think this is very important to consider several solvers. And I think that people should appreciate that and should understand that it requires a lot of work to do that. But this is also a proof of concept of the applicability of what you say. Because for some solver, you can do something in a better way than from other solver. And it depends on what you want to present. But if you want to present general stuff, it can be very interesting to have different solvers. Yes. And so I recommend to the student to use, when you develop something, for instance, with my student, we usually try to use a classical solver. And when we develop very precise thing, okay, in this case, we need a particular solver.
Okay, one last question to finish. What do you think about solvers competition?
Okay, solver competition, in my opinion, there is something that I don't understand is why people don't consider the problem of the CSP libs. You have very interesting problem in the CSP lib. I think most of the time the problem are too small. So this is good. People like to do some competition. They like to tune their solver and to spend a lot of time in tuning their solver and to refactor the code, to do a lot of things like that in order to win 2% in some part of the solver. So it's good for us. But the problem is that we have to be careful with one thing, is that the solver competition is only, in my opinion, it's not really strongly related to the power of a CP solver. Is that I think that, for instance, you have people like it was the case at iLog or IBM, they never compete with, they were never engaged in the competition, if I remember well, and I think that their solvers are professional. And so the problem is that what is more interesting is the way the MIPLib is defined. The MIPLib, when I look at that is 15 years ago, or 20 years ago, the MIPLib, I think that maybe it's still the same rule. The MIPLib was defined as follows. A problem will be introduced in the MIPLib, it's not easy to solve it by some solvers, okay? And so you need to have a certain time to be able to solve the problem. So I think that's strange that, for instance, nobody works on the Golan ruler problem, which is a very hard problem. I don't know people working in constraint programming who don't have spent, I don't know, at least 2 months on the solving of the Golan ruler problem. And you have problems in car sequencing that are very difficult, and they are still open in the CSP lib. We have a lot of problems that are difficult, and what is important, for instance, is to be able to solve problems that takes 10 minutes to be solved, at least. So now if you can solve it in 20 seconds, this is a big improvement. It means that you find something. And if you are able to solve problems that were not able to solve by anybody, that this is a very strong improvement. And if you are able to solve in half an hour a problem taking 10 hours, so this is a big improvement. But I'm less convinced by the problems that require 2 seconds when they are solved in 1 second.
Yeah.
Okay, it's an improvement. You gain a factor of 2 or maybe a factor of 3, but these are not difficult problems. You understand what I mean?
Yeah,
and that consider a large Latin square problem and things like that. And I think that we will define and we will show. I remember I attended a talk given by David Johnson, who was saying that when you give the experiment, you have to give the experiment for which your model is good or your algorithm is good, and you should also give problem for which your algorithm is not good, because we trust you. And so if I trust you, you made an advancement, and now maybe I can make an advancement and I can better understand your method by looking at the default of your method, and the default of your method are emphasized on some problems. And this is important. And so sometimes everybody has a method which works well on some problem and not well on some other problem. And so it gives the opportunity to improve the solver in general, the CP in general.
Yeah. Okay. What is the killer application for constraint programming? In which application is CP the best technology to solve the problem? Or are there, or maybe I don't know. You think there is one?
I think that this is an old question.
Yes.
This is an old question that people ask and saying, what is the killer application? I don't know what is the killer application for constraint programming. I don't even know if you need I think that for rastering, this is not bad. Huh? You can play with that. Huh? You can have a lot of information. You can explain. You can. In my opinion, it has always been the case. Is that you have a lot of information. You can work with that, because people should not forget that what is important is that there is a difference between the solving of a benchmark and the solving of the real world application. is that when you solve a real-world application, for instance, we worked on a problem in which you have hidden constraint. And when you have hidden constraint, is that when you want to identify constraint from the solution of a constraint, for instance, it's because you want to identify hidden constraint. What are hidden constraints? When you work, and I worked on problem, on real-world problem, it was for some restaurant famous in France. And then it was for the management of the waiter, the waitresses, and the cookers, on the different things. And it was for the restaurant. And then the hidden constraint was that Paul and Mary can't work together.
Ah, yes.
You cannot write it. Okay?
You cannot write it.
You cannot write it. But it's a real constraint. Because if they are going to work together, you are going to have some issues. So it will never be written, but you cannot have a restaurant which does not satisfy this constraint. And so in the real world, there are some constraints like that. And there are some constraints in which, for instance, you are a manager, you have a deal with someone, and he is not going to work, for instance, before that time or after that time because he has personal problem. And so you can consider that personal problem. But so you don't really write.
Constraint programming is good to manage very specific constraints.
But it's a way because it means that when you do something, I remember when I arrived at the university, a guy come to me and told me, "Oh, you work on constraint programming. Could you please make the rostering of the school, of the last year of the school?" I say, "Okay, give me your constraints." So I began to do the thing, and he was very happy because I was able to save half a day. Okay, and because it was his goal, he told me try to reduce the number of half days that we need to do that. We have some constraint and thing, and then I say, "Oh, you have this possibility. Oh, this one seems very nice," and he told me, "Okay, no, you don't understand. Give me the thing, give me the program. I'm going to play with it now because I have some rule I can't mention, and I'm going to finalize my rostering by including that rule and by doing that thing like that." So and I think that for a problem like that,
it's very interactive. You can.
I think that this is an example of interaction, but you can have different examples of interaction. For instance, when we work with Gilles Pesin on the sprite constraint, the idea was because in the factory, this is something that they have. In fact, you have two contradictions. Is that if you gather the thing together, then you save money, but the feasibility is bad. And if you split the thing, if you spread the different thing, then the feasibility is high, but you lose money. And so the problem is that you want to have both, which is not possible, and you have to make compromise. And so the idea is that you don't want, or you want, for instance, a rostering in which you work like crazy and then no longer work. You have some people who are happy to do that. But when you work like crazy and you no longer work, the problem is that it's very tight. Is that, for instance, we have Serdar Kadioglu who visited us, and he had a very nice remark about the optimization. And he said that in the real world, the optimization is something which is very complex because you can see the optimization at the perfect moment where the things are going to be broken. Okay, because this is totally unstable moment. The optimal point in general is very unstable because if you change a little thing, everything is changing. And so in the real world, it's very difficult to consider constraint like that because if it's too much. So in the real world, you have something that you haven't modelized. And so the problem is that it's going to be very complex to deal with the solution given by your computer. You can tag to integrate.
It's not robust. It's not robust.
It's not robust. For instance, okay, you are going to tell me, okay, I discussed with a colleague who work on the numerical twins. It's Nicolas Ayash. And he told me that, okay, we have the heart, we have something, but we don't have a body. Okay, currently, but we made a lot of progress, and now they are contacted by people like Airbus and things like that because they are very good at doing digital twins, okay, of something. They do that for the plane. Huh? You can go to Formula One and you have that for the car. And so the idea is to try to do that for human. It's a very good idea to do that. And so in this case, you can tell me, yes, but in this case, you don't want to do that. Okay. But I don't want to consider that kind of problem. I'm considering the problem that you can have, simple problem. I think that you can have. I remember a friend of mine was telling me, "Oh, Jean-Charles, I have a problem. Is that I have to manage group of people working on something for the electricity, for the lamp, for the glasses that you have to isolate." And he told me the problem is that there is a 3-step, and each people, the person of the second step has to check the work of the person of the first, and the person working on the third step has to check the work made by the person on the second step. And he told me that if they work together, after 3 days, they don't check. So I need, like, the social golfer problem. You have a kind of social golfer problem in which you want to avoid that kind of thing. But this is real world too, is that in the real world, it will also be very complex to put some people who hate them to work together.
Yes. Okay, I think it's about time to wrap up this small discussion, but I would like to finish with one question for you. Can you advise us one book to read? It can be a technical book, it can be any book that you want, but you have to pick one book that you would like to recommend.
Christopher Rapp asked me this question one day in the banquet of a CP conference, and I answered him that I have only a few books that I read. It was Graph by Berge.
Yes.
It was Data Structure by Tarjan, his small book, and I think you have the Gary Johnson book also that is less read by the young people.
With all the NPR problems?
Yeah, and because you have a compendium of NPR problem and question. And so when you have a question about a problem, it's a very nice place to look at if the problem has been proved NP complete or not. This is something
But it is more like a dictionary. No?
Well, this is like a dictionary. And I like very much too the network flow.
It's here. Maybe you can take it then.
Yeah.
Can you show it?
Yeah, I can show it. It's this one. This is a book which is very hard to find, but this is incredibly interesting, very well written, and contains so many information and very nice. It consider everything, theoretical aspect and practical aspect, and it's a very nice book.
Thank you, Jean-Charles.
Thank you.